a non-renewable energy source. Since the discovery of fossil fuels, they are one of the most important mineral energy sources. These are a finite energy resource. That means they are non-renewable resources, and once consumed they are lost forever. There are three major forms of fossil fuels: coal, oil and natural gas, and on worldwide basis they provide approximately 90% of energy consumed. 1. Fossil fuels. Since the Industrial Revolution, the major energy resources for the world have been fossil fuels formed from the remains of plants and animals lived in the distant past. Fossil fuels represent stored solar energy captured by plants in the past geological times. Coal, petroleum and natural gas are called fossil fuels, as they are the remains of prehistoric plants, animals and microscopic organisms that lived millions of years ago. These remain under the effect of intense heat and pressure underneath the Earth's crust over long geological time and got transformed into fossil fuels. For example, the gas cylinder which you see in your kitchen or coal you burn was once the sunlight captured by phototropes. During the Carboniferous period 275–350 million years ago, conditions in the world were suitable for formation of large deposits of fossil fuels. The terms resource and reserves are often used when discussing the amount of a mineral or fossil fuel resource a country has at its disposal. From a technical point of view, the term resource, when used as a measurement of mineral or fuel, refers to the total amount of a mineral or fuel in a country or on Earth. Generally, only a small fraction can be recovered. On the other hand, reserve means the deposits of energy, fuel or minerals that are economically and geologically feasible to extract with current and foreseeable technology. Coal is formed from plants and vegetation buried in situ or drifted in from outside to a place which got covered by deposits of sediments. Coal is a solid fossil fuel and a sedimentary rock composed primarily of carbon. There are three basic grades of coal: lignite brown coal, 2 bituminous soft coal, 3 anthracite hard coal. An estimated 9 meters of peat is needed to produce and form a 0.3 meter vein of coal, and it would require 300 years to accumulate that much of peat. Formation of coal. Coal is the result of plant material that grew in freshwater swamps approximately 300 million years ago. As this plant material died and accumulated, peat, also called peat bog, was formed. Since the plant material accumulated underwater, in the swamps, decay was inhibited due to lack of oxygen. Oceans inundated many of the areas of peat, and sediments from the sea were deposited over the peat. The weight of these sediments and the heat of the earth gradually changed the composition of the peat bog, and coal was formed. Today, peat also is used as a source of fuel in some parts of the world, though its high water content makes it a low-grade fuel. Peat is changed into coal after many centuries of being compressed by the weight of sediments. It first changes into a low-grade coal known as lignite brown coal. The percentage of carbon in the lignite is higher than in peat. continued pressure and heat from the earth changes lignite into bituminous soft coal. If the heat and pressure were great enough, then anthracite coal, hard coal, would be formed, which has the highest heat and carbon content. Accordingly, energy content is greatest in anthracite coal and lowest in lignite. The sulfur content of coal is important because on burning low sulfur coal emits less sulfur dioxide SO2, so more desirable as a fuel for power plants. In India, coal supplies nearly 63% of commercial energy as electrical energy generation by coal-fired thermal power stations. In industry, coal is used principally to purify and manufacture of steel. Problems. Coal is most abundant fossil fuel on Earth, but there are problems associated with its mining, transportation and use. Coal is mined from both surface mines and underground mines. Surface mining disrupts and drastically changes the natural landscape and destroys the natural vegetation and the habitat of many species, some of which may already be endangered. Mining operations, involving digging, blasting, removal of rocks and soil, lying over the coal seam, cause serious problems of air and noise pollution. Surface mining may also cause soil erosion and silt loading, the discharge of silts into streams and nalas that disrupt and pollute the aquatic ecosystems as well as groundwater in places where aquifers are located near or associated with coal seams. B. Underground mining. Underground mining may cause collapse or land subsidence in the mining areas during or after mining operations are over. In case of some mines, acid mine drainage from the mine waste and dog piles polluted long stretches of streams. Coal fires in underground mines may happen, which naturally give out much smoke and hazardous fumes, caused several respiratory diseases to people living nearby. Apart from these problems, burning of coal in thermal power plants for generation of electricity and in industry is a prime source of air pollution. B. Petroleum or mineral oil. Oil and gas were formed from the remains of plants and animals that once lived in the sea. For over millions of years, these remains remained buried under mud and rock, under great pressure and at high temperatures. Under these conditions, marine biomass gradually changed into oil and gas. Oil and gas are primarily found along geologically young tectonic belt at plate boundaries, where large depositional basins are more likely to occur. Petroleum or crude oil as it comes out of the ground is a thick dark liquid consisting of a mixture of hundreds of combustible hydrocarbons along with small amounts of sulfur, oxygen and nitrogen impurities. It is also known as conventional oil or light oil. Deposits of crude oil and natural gas are usually trapped together under the seafloor or Earth's crust on land. After it is extracted, crude oil is transported to a refinery by pipelines, trucks or ship's oil tanker. In refineries, oil is heated and distilled to separate it into components with different boiling points. The important components are gases, gasoline, aviation fuel, kerosene, diesel oil, naphtha, grease and wax and asphalt. Some of the products of oil distillation are called petrochemicals, which are used as raw material for the manufacture of pesticides, plastics, synthetic fibers, paints, and medicines, etc. The consumption of petroleum products is rising worldwide. In India, the demand has risen from 57 million tons in 1991 to 1992 to 107 million tons in year 2000. The India Hydrocarbon Vision 2025 gives the projected need for petroleum products for India to be 368 million tons by 2025. See natural gas. Natural gas, primarily consists of methane, is often found above reservoirs of crude oil. The natural gas is a mixture of 50 to 90% by volume of methane CH4, the simplest hydrocarbon. It also contains small amounts of heavy gaseous hydrocarbons such as ethane C2H6, propane C3H8 and butane C4H10, and also small amounts of highly toxic hydrogen sulfide H2S. Natural gas is formed through geological processes, similar to the processes of crude oil formation described earlier, except the organic material gets changed to more volatile hydrocarbons than those found in oil. Almost every oil well produces liquid petroleum along varying amounts of natural gas. However, there are large gas deposits without any liquid petroleum being associated with them. Conventional natural gas. It lies above most reservoirs of crude oil. These deposits can be tapped/used only through pipeline. But the natural gas that comes out along with oil is often looked at as unwanted byproduct and is burned off. Burning of associated natural gas represents a waste of a valuable energy resource and emissions carbon dioxide into the atmosphere from its burning. But after the gas is processed, it is piped or compressed into cylinders for use by consumers. This gas is also used for the production of petrochemicals and fertilizers. Unconventional natural gas. It is found by itself in other underground reservoirs. So far it is very expensive to get natural gas from such unconventional sources, but technology is being developed to extract the gases economically. When a natural gas field is tapped, propane and butane gases present in natural gas are liquefied and moved as liquefied petroleum gas LPG. LPG is stored in pressurized tanks or cylinders for use as cooking gas. At a very low temperature, natural gas can be converted to liquefied natural gas LNG. This highly inflammable liquid can be shipped to other countries in refrigerated tanker ships. The production and consumption demand of natural gas has been rising in India for both industrial and domestic uses. After the gas is processed, it is piped or compressed into cylinders for use by the consumers. Problems associated with oil and gas. 1. Leakage of natural gas from pipelines, storage tanks and distribution tanks is potential cause of explosion. Methane, being major component of natural gas, happens to be a Greenhouse gas and its leakage contributes to global warming. But being a clean fuel has advantages over coal and oil and preferred as a better fuel option or energy resource. 2. Extraction of oil and gas may cause sinking of land or subsidence. For example, in Long Beach Harbor area, in Los Angeles, USA, intensive oil extraction beginning in 1928 caused severe land subsidence. Over the well sites, the ground dropped 9 meters. Extensive subsidence created a need for flood control measures along the coastline. Damage to buildings, roads and other structures were estimated at $100 million. 3. Another major problem in the past with onshore oil wells has been brine salt water. Typically, for every barrel of oil production, 10 barrels of brine are also extracted. In early days, the brine was simply discarded into nearby streams or on the soil. Today, most brine is reinjected into the well. However, brine can contaminate fresh water aquifers if the casing lining the well is missing or corroded. 4. Apart from these two problems, oil also contaminates the oceans. About half of the oil that contaminates the ocean comes from natural seepage from offshore deposits. Annually, approximately 600,000 metric tons of oil seeps into the ocean from natural sources. 20% of the oil contaminating the ocean comes from oil well blowouts, pipeline breaks and tankers. The rest comes from oil disposed of inland and carried into the ocean by rivers. Leakage from offshore wells also occurs during the transfer of oil to shore and also during normal operations. The harmful effects of oil's contamination are felt both in fresh water and marine water environments. Oil kills aquatic plants and animals. After a major spill, it may take 2 to 10 years for the organisms to recover. Combustion of oil and gas also causes air pollution. Even though the natural process of fossil fuel formation is continuing today, but the rate of production is very low. For all practical purposes, the world's supply of fossil fuels is limited to what was formed 300 million years ago. When this supply is exhausted, we will have no more supply. As a result of realization, people have started exploring and use alternative sources of energy. Location of fossil fuel deposits in India. India has large reserves of coal, and lignite is found in West Bengal, Bihar, Orissa, Madhya Pradesh, and Andhra Pradesh, as well as in Assam and Tamil Nadu. Oil and natural gas are exploited both from inland and offshore sites. Some of the major oil reserves are located in West Coast, Gujarat, Rajasthan, Godavari and Krishna Delta on the East Coast, Assam. Uses of natural gas. Natural gas is a relatively clean fuel, burns readily to produce large amount of heat. That is why natural gas is used as the main fuel for domestic and industrial heating purposes. It is used as a fuel in thermal power plants for generating electricity and a feedstock for manufacture of fertilizers. Compressed natural gas (CNG) is being increasingly used as a fuel in transport vehicles, buses, trucks and cars. CNG is a good alternative to petrol and diesel because it causes less pollution. These days in Delhi and some other cities are using since the use of CNG as an alternative fuel for automobiles has started. Air pollution levels have decreased perceptibly. Natural gas is used as a source of hydrogen gas needed in fertilizer industry. When natural gas is heated strongly, the methane present in it decomposes to form carbon and hydrogen. This hydrogen gas is combined with nitrogen gas to manufacture of ammonia NH3. Reaction of ammonia with acids forms ammonium salts. These ammonium salts are used as fertilizers. Natural gas is used as a source of carbon used in tire industry. When natural gas is strongly heated, then methane gets in it decomposed to form carbon and hydrogen. The carbon thus formed is called carbon black and used as filler in the manufacture of tires. Advantages of natural gas. Natural gas is a clear and environmental-friendly fuel and used directly for cooking purpose in homes. It can be supplied directly to the homes and factories through a network of underground pipelines, thus eliminate the need for additional storage and transport. Natural gas burns with smokeless flame, and on burning does not produce any poisonous gas or pollute the environment. Friendly gas. Your energy sources.